This video is on the objective: calculate and interpret the confidence interval for a population mean with a known standard deviation, but with the use of a calculator. So this is just like another objective from this section, this particular Newton-Alta homework, but with calculator use. I'm going to show you what I'm going to do on the TI-84 Plus. TI-83, TI-84 are very similar, and if mine doesn't have exactly what you're looking at, you can click on more instruction and see how they're doing it in the calculator, and how they show you how to do it. Okay, so like I said, if you want to see how they're showing you how to use the calculator, click on more instruction and view how they're entering things in the calculator to find these confidence intervals. So the number of ads on a corner in the city are normally distributed with a population standard deviation of 7 ads, right? So that's sigma, population standard deviation 7, and an unknown population mean, right? So mu is unknown. And we use a confidence interval to guess what mu is with a certain amount of confidence. So if a random sample of 20 corners is taken and results in a sample mean of 21 ads, use a calculator to find a 95% confidence interval for the population mean and round your final answer to decimal places. Alright, so you just have to pay attention to what's what here. They gave us sigma, 7. They gave us n, right? The size of the sample is 20. And they gave us the mean of that sample, the x bar, right? 21. And they also gave us the confidence level. Now you're going to have to put it in as a decimal, not a percentage. So not 95, you're going to put in 0.95. All right, so let me show you the calculator. So again, TI-84. Let's get rid of this stuff. Now, how do I calculate a confidence interval estimate for a mean with the calculator? So hit the stat button, hit stat, and you go over to tests. And right now, we're doing an estimate, a confidence interval estimate for a single mean, right? One population mean, and sigma is known. Now, if you recall from earlier objectives in this section, because sigma is known, right? In order to calculate the margin of error for our intervals, we ended up having to find some sort of z-score, right? There was a z-score, that z sub alpha over 2. So if you scroll down, you see all these ones that end in test. Look at number 7. Okay, number 7, it says z interval. So that's z interval means, I'm using z-scores to find an interval for a mean. All right, this is a one mean confidence interval where sigma is known. All right, we'll do this next one that says t interval. We'll use in a later section, a later homework, when we're doing an interval estimate for a mean when sigma's not known, unknown. But here sigma's known. So go down to number 7 where it says z interval. Then it's going to ask you, do you have a list of data, or do you just have statistics? I do not have a list of data here, right? Look at the problem. I'm not given a list of data, right? So you don't have to enter a list of data. Now, if you did, you can just go here and just enter what list did you enter the data in, list 1, list 2, list 3. But I'm just given statistics, so I go over to stats, hit enter there, and then fill in the proper information. What's sigma? That was the 7, right? They said population standard deviation of 7 ads. What was the x bar? That was the sample mean, and that had a sample mean of 21 ads. The calculator's hiding it right now, but remember, sample mean of 21 ads. So x bar, 21. N, what was the sample size? 20, right? They sampled 20 corners. And then what's the C level? That's the confidence level. which is 95% here. Again, 0.95. Now it's already entered 0.95. But if they want 98%, you put in 0.98 and so on, right? You'd have to change this. But right now I don't need to change it. It's already 95%, 0.95. But make sure you enter it as a decimal. And then calculate, and there you go. Right up top, there's the confidence interval, the 95% confidence interval estimate for the mean number of ads on a corner in the city, the mu. So we'd say with, I'm 95% confident that the average number of ads on all the corners of this city, right, the population, are between 17.9 and 24.06. Right? And they all want us to round these values to 2 decimal places. So back on the website, the lower value, 17.93. The upper value, 24.068 or 24.07, to 2 decimal places. And then now that I have these, you could find the margin of error by taking the distance between these and then cutting them in half. Remember, when you're given an interval, you can easily find the margin of error. Make sure that the sample mean, the 21, is exactly halfway between, and it is. I would add 3.07, subtract 3.07. All right, the sample mean, that point estimate, should be exactly halfway between these. Again, the margin of error is 3.07, right? It's just the distance from the middle to the top or the middle to the bottom, or you take the distance between these and cut it in half. You get the margin of error. So you could also use the calculator to find margin of error pretty easily. And that's it. Let me get rid of the calculator here, submit. That's all we had to do. Just go to that Z interval. And they explain it all down here. Same stuff. All right. So that's one question. I think I'll do one more, just because. So one more video coming up on this. Thank you very much for watching.